This is video number 3 for section 5.6, evaluating logs on the calculator. This is something I know you've been wanting to know for a while now. Some of the newest TIs can handle logs with all sorts of different bases, but on most calculators you just see that LOG button, that log base 10 button. So how then do you find other logs using a calculator? For example, here's log base 7 of 2.6458. I got this from the last example of the last video. We were solving an equation. The solution came out to be this 2.6458. Well, let's say we wanted to check it. Let's say we wanted to plug that number in for x and check it. One of the things we'd have to calculate in that equation was log base 7, 2.6458. How can I do that? Well, it turns out that there is a rule that we need to develop. Let me see if I can help you see where that rule comes from. What I'm going to do is I'm going to call this thing that we want to figure out capital A. So A is this power that we're looking for. As soon as I write that down, hopefully what you recognize is that this equation is now in log form. One log, one base, one result, one power. Well, anything that's written in log form, we know we can switch to exponential form. Let me do that. It's that pathway idea. 7 to the A equals 2.6458. A, remember, is what I'm looking for. I'm trying to figure out what A is equal to. Well, this equation is now what we have been calling an exponential equation. Something to the something equals something. That's in exponential form. And our strategy for solving exponential equations, where the unknown is in the exponent position, has been get yourself in exponential form and then log each side. And when we say log, we've been meaning the base 10 log, LOG. Why in the world would we introduce something so complicated? Well, because once you introduce logs on the left side, you can use that power rule. I can take this power and I can move it to the front as a coefficient. Let's write down now what we have. And then to get A by itself, if I just divide both sides by log 7, I'm done. And so now we have A is equal to log of 2.6458 divided by log of 7. Well, remember, A was what we were looking for. A is this. We've just come up with a way to calculate what we were looking for using the LOG button on the calculator. Well, that leads to what's called the change of base property for logs. And I think it's a pretty easy pattern to see from this one example. What we're basically saying is this. If you have some log with some base other than 10, and you would really like to work that out on the calculator, according to this pattern we just developed, it looks like you can do that by simply taking two LOGs. Now, where did that 2.6458 number come from? That was the previous result, in this case the X. Where did the 7 come from? That was the previous base, the B. This is an awesome property because it says if you have a log other than 10 with a base other than 10, you can always just switch it into this other format and then you can type it right into the calculator. That's called the change of base property for logs. Technically, you can change to any kind of base you want. I mean, I didn't have to use base 10, but base 10 is the one we generally use because it's the one on the calculator. Let's wrap this up by going back to our problem here. Let's go to the calculator and type this in. It would be simple. Just type it in exactly as it looks using the division sign for the fraction bar. What you get is right about 0.5. In fact, it almost seems a little too perfect. Why would that come out so nice like that? Well, that goes back to that last example. If you look back at your notes from video number 2, that final example, the 2.6458 number, that came from typing 7 to the 1/2 into the calculator. Well, I'm sitting here trying to figure out log base 7 of 7 to the 1/2. That's what this is. I don't need a calculator to do that. This is very, very easy. This means what power do I put on top of 7 to get 7 to the 1/2? Well, obviously, that would be a power of 1/2. 7 to the 1/2 equals 7 to the 1/2. So that's why the calculator is telling us 0.5. The great thing about the change of base property, though, is even when I have no possible way of working these things out by hand, I now have a very, very simple way to work them out on the calculator. Let's finish with this one last example. This has nothing to do with any other problem we've looked at. It's just a fresh example, log base 9 of 47.53. I have no idea how to work that out by hand. I know what it means. It means 9 to the I don't know equals 47.53. Let's see, 9 squared is 81. That's too big. 9 to the 1 is 9. That's too small. That's about all I know. I don't have to wonder anymore, though, because the change of base property says that I can use the LOG button with this simple division problem. Log of the previous result is what goes on top, and then log of the previous base is what goes on the bottom. Just type that into your calculator and you're done. I got about 1.7574. Make sure that you're typing this in to your own calculator to make sure that you know how to get that answer.